Iron Beam, the laser shield. In the skies above Israel, threats of rockets, mortars, drones and missiles rain steadily. For years the country has relied on layered missile defense systems. But now a new era is beginning, where lasers, not rockets, may become the shield. This is the story of Iron Beam, a high-energy laser air defense system developed by Rafael Advanced Defense Systems, with Elbit systems, designed to engage short-range threats at the speed of light. In this documentary we'll explore how it works, why it matters, its place within the broader defense architecture, its advantages and limits, and what it might mean for the future of warfare. The threat landscape. Israel has long faced a complex threat environment. Rockets and mortars fired from nearby territories, unmanned aerial vehicles sneaking in from above, cruise missiles and swarm attacks. The challenge: many threats arrive too fast, too low, too small for older systems to catch, or they come in mass. For example, the widely deployed Iron Dome system intercepts short-range rockets in the 4 to 70 kilometers class, protecting populated areas from barrages. But even Iron Dome has a cost. Each interceptor missile costs tens of thousands of dollars, and in a saturation attack the volume of threats strains the system. Enter the idea of a new layer, a laser defense system that could fire virtually unlimited shots, at minimal marginal cost, to shoot down rockets, mortars, drones. A final line of defense. Origins and development. The Iron Beam project was first unveiled at the Singapore Air Show on February 11, 2014 by Rafael. At its conception, it was to become a directed energy air defense weapon, capable of engaging short-range rockets, artillery and mortars, and unmanned aerial vehicles. Over the years the system's laser power steadily increased, with companies like Elbit awarded major contracts to supply high-power laser modules for the system. By 2024-25 the Israeli Ministry of Defense announced the system would be integrated into Israel's multi-layered air defense architecture, alongside Iron Dome, David's Sling and Arrow. How Iron Beam works. At its heart, Iron Beam is a high-energy laser weapon system, HELWS. According to Rafael's specifications, it features a 100 kW class fiber laser, adaptive optics and coherent beam combination to deliver precise energy onto a target. Unlike traditional missile interceptors which launch a physical missile to meet an incoming threat, Iron Beam emits a concentrated beam of light that, once aimed at the target, can destroy or disable it within seconds. The advantage: speed, virtually the speed of light, minimal magazine constraints, as long as power supply holds, minimal collateral debris. Typical engagement sequence. 1. Threat detected via radar/EO sensors. 2. Target tracked and handed to laser director. 3. Beam maintained on target for a few seconds until target is neutralized. 4. System resets for next target. The system is designed to integrate into existing air defense command and control. It is particularly suited for short-range threats, rockets and mortars whose flight time is very small, that escalate the cost and complexity of using missile interceptors. Rafael claims that per-shot cost is dramatically lower, just dollars, compared to tens of thousands of dollars for missile interceptors. Integration within Israel's multi-layer defense. Israel's air defense philosophy is layered. At the top you have the Arrow 3 system for ballistic missiles, then David's Sling for medium-range missiles, then Iron Dome for short-range, and now Iron Beam adds a new very short-range, directed energy layer. Its role: to complement the existing interceptors by taking on hundreds of smaller and cheaper threats, and to reduce the burden on expensive missile interceptors. The Ministry of Defense describes Iron Beam as complementary and part of the integrated architecture. In a scenario of mass rocket fire, the interceptors target the highest threat first. Iron Beam could engage the more numerous, smaller, cheaper threats, leaving missile assets for the bigger ones. Advantages and game-changer potential. What makes Iron Beam so potentially transformative? First, each interception via laser costs only a few dollars, or at least orders of magnitude less, compared to interceptor missiles costing $40, 000, 50, 000. Second, virtually unlimited magazine. As long as electrical power and cooling exist, The system can continue firing, unlike missiles which must be loaded and replenished. Third, rapid reaction time and high precision, ideal for swarms of drones or mortar/missile salvos where flight times are short and quantity is high. Fourth, minimal debris. Since the threat is destroyed by energy and not an exploding interceptor, collateral damage risk is lower. In short, this is a potential cost immunity weapon. Defense cost per shot drops, while adversary attack cost remains the same or rises. One analyst called it a game changer. Limitations and realistic boundaries. But no system is perfect. Iron Beam has limitations. Range/flight time. While laser engagement is very fast, the target must be tracked and held in the beam for a few seconds. This makes longer-range threats more challenging. It is optimized today for very short-range threats. Atmospheric/visibility conditions. Clouds, dust, rain, fog and turbulence can degrade the laser's beam quality and reduce effectiveness. For this reason, the system is designed to complement, not replace, missile interceptors. Power/cooling/logistics. A high-energy laser system demands stable power supply, cooling and infrastructure. It is not as mobile or flexible as an interceptor rocket battery. Reports noted that mobility was constrained for earlier versions. Saturation and multiple simultaneous threats. While laser engagements can be rapid, when faced with hundreds of simultaneous incoming threats, the system's capacity may still be challenged, especially under adverse conditions. So, while Iron Beam is potent, its deployment is about augmentation, not substitution. Test and field deployment. In September 2025, the Israeli Ministry of Defense announced that Iron Beam had completed full operational configuration testing, intercepting rockets, mortars, aircraft and UAVs in various scenarios. The system is slated to enter service by end of 2025 and be integrated into the existing defense network. While widespread combat deployment is still to be observed, the maturity and funding of the project indicate that it is no longer science fiction, but real-world imminent capability. As the nature of aerial threats evolves, with drones, hypersonics, swarms, cheap rockets, so too must the means of defense. With Iron Beam, Israel is placing a bet on directed energy as a core component of that defense. If the system works as intended, the cost balance shifts. Defense becomes cheaper, more sustainable, and more resilient to mass attack. For adversaries, cheap rockets may no longer deliver the economic edge. Yet the future remains dynamic. Will laser systems scale to meet future high-speed threats? Can they be mobile and global? Will other countries adopt similar approaches? One thing is clear, the era of lasers in warfare has arrived, and Iron Beam may be its first operational usher.